Hello Amy, I'm going to record myself for the seventh time to show you how I solved the exam 2. Let's begin. Okay, so for part A, I used this formula right here because the membrane is infinitesimally small, so it applies. And for the constants, I just took them out because they won't affect the electric field at all, so you just take them out, and this is the what I got for the electric field on A and the electric field for B. Therefore, the electric field on A is greater than the electric field on B. Moving on to part B, the ratio of the electric field, I used the same formula because of the same reason, and I just put the electric field of A over B to get the ratio. So I got, that's how I was able to get 1.0024 ratio from A to B. And for part C, for the capacitance, I use the capacitance formula that equals charge over the delta voltage. And for this voltage, I use this formula right here for the shells, and so after that I was able to get the integrand of the derivative of B, which will give me this. That way the charges will cancel out right here, so therefore the capacitance after doing all this math will equal 2.32 times 10 to the negative 8. And for part D, so I used this formula for discharging capacitance, and since the discharge here is about 0.5 seconds, that's my time roughly, and my capacitance from part C, I used it as well, and that way I just solved for C using this formula, which is how I was able to get R equals negative T over the natural log of V final over V initial times capacitance. So however, since these are millivolts, I changed the millivolts to volts, and that's how I was able to get this from that voltage, and then I multiplied it times the capacitance and divided the time. I divided it by all that to get 3.78 times 10 to the 6 ohms.